All right, so today, like what I normally do before I go into a lecture, I like to just give like a bunch of code examples of what to expect from the chapter. So that's what I'm gonna do today. I'm gonna do the same thing, except I need to like explain the whole concept behind chapter 4. So the idea behind chapter 4 is that we are now going to separate. I guess I should draw this up. Hold on. All right, so the idea behind chapter 4, like, what the heck? How do I get rid of this? Go away. Okay. So right now, like, all our programs have just been like in one file, right? So, like, we have data. So, like, here's our program right here, right? Like, we write a bunch of code here, okay? And this program that we're writing is like the interface to the user. You have a user right here using the program. And then it also is storing like data. Like here's like all the data variables, right? So they're asking him for the name. He enters in his name. So you have like username and his age. Like you're writing programs to where we're storing all this information. So we're providing like the interface, right? Which is how we interact with the user. And then we're also like storing and managing data in the same program. Okay, so the concept behind chapter 4 is now we are going to make two files. Okay, we're gonna make two files, and one file is gonna just be a class definition that is like gonna have like data that we're managing for some particular I don't know, for some particular type, and then we're gonna have one file which is gonna be like the interface to the user. Okay, and we're gonna pull the data from this class here. And we're gonna like make an instance of it, and we're gonna like use that object to pretty much manage the type of data that we're asking for. All right. So let me see. The best example I can do to help show why this is important is if I make a student class, or excuse me, make a program where I'm prompting the user for his name. Why isn't this saved? I don't know where these files are from. Oh, that's okay. Okay, I'm going to make a program that is going to prompt the user for like just like for student information, like the name, and then maybe like 3 test grades, something really simple like that. Okay, so let me make a folder here, and I'll call it chapter 4. Okay, I'm gonna call this one grade calculator. I can't see the Java. Am I blind? Down. Oh. Okay. All right. So public class, and then the name of my class, grade calculator. All right, so we're gonna write a program that's gonna prompt the user for his name, like he's a student, and like his 3 grades that he got on a test, right? Like 3 test grades for the semester, and then calculate his test average. So I am gonna have to import the scanner because I'm gonna ask the user for information. Okay, then I know that I want to have like a string for the name of the student, and then I want to have maybe like float for like test 1, test 2, and test 3. So like enter your name, or actually let me come up here really quick because I do want to calculate and store test average. And then I'm going to have a constant for the number of tests. All right, so I'm going to prompt the user to enter his name. He's going to enter his name. I'm going to store and say name is equal to this last string that the user entered. I'm asking for test number 1 grade, and I'm going to store that. There. All right, let me copy this, paste it 2 more times. All right, ask him for test number 2 and test number 3. 2 and 3. All right, then I can say like test average is equal to the sum of test 1 and test 2 and test 3, all divided by the number of tests. All right, and then I can give him like a nice little display where I have like his name and grades and his average. Okay, so I'll do something like this. Okay, I'm just going to copy this. All right, and let me just copy this as well. All right, so to have a really simple program, really all I'm doing is prompting the user for data and storing it into his variables, calculating test average, and outputting that information back to the user. All right, so let me go ahead and compile this and run it. I'm going to go over here to containing folder, CMD. All right, I'm going to say Java C, and the name of my program is Grade Calculator. I'm going to run my program. Okay, your name, I'll just say like Bob, and then test 1 was a 67, 89, 98. And dang it, I did not put my test average. What the heck? Nobody stopped me on that one. All right, so let me just add one more line over here and say test average. All right, and try this one more time. Wait, I didn't mean to do that. We got to recompile. All right, so Bob and 67, 89, 98, and then there are his 3 test grades that he entered, and there's his test average. Okay, I mean, pretty simple stuff. Now, just to say, you want to do the same thing for another student, right? Or you want to make a program that keeps prompting them for student grades, and it's just storing all this information. Now, the problem you're going to run into is that for every student, you're going to need another student name and 3 more tests, right? For every student that you want. Like, if to say this program is continuous, like the first thing is like, you know, they ask like, oh, how many grades do you want to enter, or how many students would you like to enter? And you say 5. So then at that point, you're going to prompt for 5 names, 5 test grades, right, over and over and over again to get all the information. So if you're making that program, it is doable. I mean, you're going to have to create a bunch of variables here, right? And maybe rename them to where it says like student 1, test 1, right? Student 1, test 2, then student 2, test 1, right? Something like that. Or what you can do, which is also like really helpful and help managing your data, is you can make a class that is designed to create the concept of a student object. Okay, so like the whole idea behind objects is they're going to have data that they're going to maintain, and you're going to provide public methods that we can use in order to get and set these values. Okay, so the concept is, if I draw it up, let me see. Let me draw it up. Okay, so the idea is I'm going to write this class, and once I write this class, I'll be able to make a student object. Okay, and then like just say this, the name for the student is Bob, and then he has like test 1 is 67, test 2 is what did I say, 89, and then 98 for test 3. All right, so what we're going to do is this data is contained within this object. Okay, but we're going to provide methods that allow us to access that data. Okay, so like one of them would be like set test 1, right? And we're going to take in a float, take in that data and change what our test 1 is, right? We're also going to have like one called like get test 1. Okay, and what we're going to do with this method is get the value that's stored in test 1 and then give it back to whoever's calling this, right? So it is going to be like here's like the program that we created. So instead of making all these variables for student, we just instantiate our concept of a student object, and then we can invoke methods to get and set the test grades and also calculate the average. All right, we can have a method to calculate the average, and we can get it as well. We can get the name, set the name. We'll be able to do things like that. So this data is kind of managed within this class, right? In this instance of this class. So over here, if I wanted 2 students, I can create 2 student objects. And now I'll be able to manage 2 student objects. And maybe like this student's a different one. His name is Mike. His grades are much better. And his average is much better. Okay. So, but he would also have services that he has for setting and getting and calculating the average. All right, so let me go ahead and just type that up. So I'm going to make a class for my concept of a student object. So I'm going to come over here to new, and normally what we do is we give our class a name that describes the type of object it is. So in this case, we're going to say it's a student. All right, so the way this class is written, it's going to be public class, same way. There's no main method in this class. All right, so in any one program, you can only have one main method. So we want to use student over here instead of having all this data over here, and we're going to have our main method over here and not over here. But what we're going to do inside of this class is we're going to declare our variables. Now, our variables that we declare have to have what we call visibility modifiers. Okay. And what that means is we tell Java if we want our data to be public or private. Now, to comply with the rules of encapsulation, instance data is always private. So I'm going to have a private string name, and then private float test 1, test 2, test 3. I can also have my constant up here. It doesn't need to be private because it is a constant. So you can say something like public final int num of test grades, or actually number of tests. All right, and we'll set that to 3. Okay, so let's talk about this one more time. Is these visibility modifiers tells Java where that data can be accessed. If it's set to private, that means that that data can only be accessed within this class. Within this class is within these curly braces right here. That it can't be accessed anywhere else. Okay, so the idea behind encapsulation is that we encapsulate our instance data and we provide public methods to modify that data so that we can use any type of filtering requirements if we need to. All right, so what I'm going to write is what we call boilerplate code. Whenever you have instance data, it is typical to write getters and setters for that instance data if you do intend for whoever is going to use this class to get and set that data. So for instance, I want to provide the service for somebody to come in here and set or change the name of the student. So I'm going to say public void set name, and it always follows the pattern set, and then the name of the instance data, in this case, name. We're going to take in a string, right? And we can give this string any variable name. This variable is going to be a local variable to this method. We'll just say n, and we're going to say, okay, well, whenever we pass in a string using the set name method, we're going to assign that value to name, right? That's the whole point of the set name method, is to take in a value and change the name of this object, right? The tests are going to follow the same pattern: public void set test1, but the data type for test1 is a float. So I want to take in a float, and I want to take in a test grade. I'll just give the variable name t for now, and I'm just going to say test1 is equal to t. All right, so whatever data comes inside of here, we're going to assign it to test1. And this is just a placeholder, just to let Java knows that your method takes a string or it takes a float, and we just make up our own identifier for this variable. I'm just going to copy what I did for test1 twice. Wait, that was 3 times. All right, twice, and I'm going to change these method names to match what I'm doing, which is set test2, set test3, and assign test2 equal to t, assign test3 equal to 3, or equal to t. All right, so I just created 4 setters because I have 4 pieces of instance data. This constant is not instance data, it's a constant, it's just some number that remains the same all the time. The only data that actually can change is the name, test1, test2, and test3. I now provided the service to set those values. Now we also want to provide the service to get those values. Okay, it follows a similar pattern. It's public because we want this service to be called through the object. So we make it public, and we got to return some type of data. The data that we want to turn is a string for the name, and we're going to follow the pattern get name. Okay, so it's set name, get name. That's the pattern. For setters, typically you don't return anything, so you use the term void, meaning this method is not going to give you back a value. The method is performing some action. It's taking in a string and changing the name for whatever string that was passed in. Okay, for the getter, we're actually going to return back a string. We're going to just we're going to define this method as public string get name, and then return back the name. All right, and we're going to do the same thing, follow a similar pattern for our test. So public float get test1. Okay, I'm going to do this 2 more times. All right, and there's more methods that I would want to add to make this student object a little more useful, like calculating the test average. But for now, let's go ahead and use this student object. Okay, so I'm going to make a new program. I'm going to copy what I did here, but I'm going to make a new program. But I'm going to call it grade calculator 2, and then we can look at the difference between the two. I'm going to come over here, new, and I'm going to come here and save as grade calculator 2. Okay, I know I want to use the scanner because I'm still going to prompt the user for data. The name of my class here is public class grade calculator 2. And I need a main method, public static void main string array arguments. All right. All right, so I'm going to declare my scanner. All right, and now what I'm going to do is I don't really need to have a bunch of data, right? Because I know that my student object is not going to manage all that information for me. So all I really have to do is make a student object called student, and we'll just say, I don't know, S1. Okay, and so we'll say new student. Okay, now this is what we call the constructor of our student. Our constructor is the initial method that is called whenever we instantiate an object. Now we did not define a constructor in this class. All right, we only have getters and setters. Let me label all this. And then down here we have our getters. Okay, there's no constructor defined. I will show you how to make your own constructor. So the student class, if you look at it, it's pretty simple. I know it seems like a lot because I have all these methods associated with it now, but really I have just 4 items of data: a string for the name, and 3 grades for that are floats for test 1, 2, and 3, and I have setters for name and test 1, 2, and 3, and I have getters for name and test 1, 2, and 3. All right, it's pretty simple. So over here, I instantiate my student object. Now, since I don't have a constructor defined, then Java will automatically have what we call our default constructor that does not take any data, right? I don't pass anything inside of those parentheses. It's just the name of my class, open close parentheses. The new keyword tells Java that you want to instantiate a new object and put it into memory, and then the constructor will tell you the type of object that you want to create. Okay, so using the same prompts, I'm going to say system.out.print, enter your name. You're going to give me name, and let me just write out all the prompts. All right, I'm just going to copy what I did over here for the output. I'm going to have to change it, but I don't want to have to retype all of this. All right, so I have prompts, and I have the data that I want to show. So I'm going to come in here. I'm going to fill in this data using my class now. So I'm going to say s1 dot set name, open close parentheses. Now here's the part where it gets kind of funky, is that instead of using the assignment operator, we are going to pass in the string that we get from the scanner by putting it inside of the parentheses. So I'm going to say scan.nextLine inside of the parentheses for set name. I know that seems weird, but that's the way we're going to do this. And we're going to do the same thing for set test1. Inside of the parentheses, I'm going to have scan.nextFloat. All right, I'm going to just copy this a couple of times. Okay, and still my student number or my S1, and there's my test 1, here's my test 2, and here is my test 3. All right, now I don't have a service to calculate my average, so I'm going to leave that off for now. But if I want to get my name, right, name does not exist anywhere. If I were to compile and run this, Java will say cannot find symbol, because this class cannot see these data variables in this other file because we declared it to be private. Okay, so they cannot be seen. If we want to get the name of our student, we just say s1.get name, open close parentheses. Right? We're calling the methods on that object. s1.get test1, open close parentheses. s1.get test2, open close parentheses, and s1.get test3. Okay, this line here I'm going to comment out for now because I don't have a test average just yet. Okay, so let's talk about what's happening here. Okay, so before I compile and run this program, I imported my scanner class. I instantiated the scanner object. I instantiated a new class that I created called student, and I named it S1. Okay, I prompted the user for his name, just like I did on my other program, where I prompted the user for his name and his 3 test grades. Okay, the only difference between the 2 programs is that I have all this data inside of the same file. On this program, I decided to use the student class, which is class that is pretty much going to manage this data for me. Okay, So to set the name, I call set name on my object. To set test1, I call set test1, set test2, set test3. And when I'm ready to get that information out of my object, I call the method get name, get test1, get test2, get test3. Right? Pretty simple. So I'm going to hop over to my command prompt, clear my screen. Now I'm going to compile only, there's two Java files. I have the student and I have the grade calculator 2. I'm only going to compile grade calculator 2 if, actually, let me do this. If I type dir, you can see that I have my grade calculator and I have the class file of my grade calculator. Remember, the class file is the bytecode that Java actually reads. So when you compile a Java file, the class file gets generated. If you cannot compile your program, then no class file will get generated. So I'm only going to compile grade calculator 2, but since grade calculator 2 uses student.java, Java is automatically going to compile the student.java as well. Okay? So I'm going to hop over here and compile grade calculator 2. It compiled. I'm going to type the command dir so we can see what files are generated. So here's my grade calculator 2.java. Just above it is my grade calculator 2.class. Here is my student.java, and just above it is my student.class. So because I use the student class in the grade calculator 2, the student class also got compiled when I compiled grade calculator 2. Okay, let me clear my screen, and then I'm going to run the grade calculator 2. Okay, running just the same. So far I can tell no difference. Okay, test grade 1, test grade 2, test grade number 3. Press enter, and I pretty much got the same output. Did I enter 89 twice? I did. All right, so there's my output. Now I am not getting my average. I have two options. I can come over here and I can make the same equation and just say like get test 1 plus get test 2 plus get test 3, sum it, and then divide it by 3. Or I can come over here and I can provide a service that does this for me. Now a big mistake that a lot of students make is they come over here thinking, oh, I'll just put a test average here. Okay. Now the reason why this is a big mistake is because test average is dependent on test 1, test 2, and test 3. So if we were to update test 1, 2, or 3, then the test average is no longer valid, right? So whatever we had calculated before is going to be invalid, like as soon as they go back to update test 1, 2, or 3. So for things that are dependent on other variables, right, like test average, we do not actually make a variable for them. We just provide a method that will do the calculation for us. So over here, I'm going to make a method called public float, because I'm going to return the test average. I'm going to say calc, like cal for calculate test average. Now the reason why I didn't use get test average is because I don't want to make that mistake of seeing get test average and then thinking there's an actual instance data variable for test average when there isn't. Okay, so this method, every time it's called, it's going to calculate whatever my test average is. And the way I'm going to do this is I'm going to get my sum. I'm going to say sum is equal to test 1 plus test 2 plus test 3. Okay, and then I can just return sum divided by the number of tests, and that will give you my test average on demand. Okay, and because I'm returning a float, wherever I call this method, I can expect a float to be at that location. So I can go ahead and uncomment this line, and under test average, I can just say s1 dot calc test average. Open close parentheses, it is a method. And now what's going to happen is we're going to call this method. This method is going to get invoked. It's going to check, it's going to sum up all 3 test grades, and then it's going to divide the sum of the 3 test grades by 3 and then return that result. So now when I come over here to my screen, clear and compile, and then run. I'll enter in my grades. And there is my test average. So it's providing the same services that I had before, but now when I ask, okay, well, write a program that can read information for 5 students, then all I have to do is say, okay, well, I know I need to manage 5 students now. I can make an object for S1, S2, S3, S4, S5. Now I do need to write all these prompts out for each one, but when we get to chapter 5, we can enter in a loop. We can make that so much more easier, right? But the idea behind chapter 4 is pulling out that data from your program if it can be an object. Okay, does that make sense? Okay, so this is chapter 4. I know for some people it's like, whoa, like that's super complicated. I have no idea why it's super complicated. I think maybe because you're using 2 files and they're talking to each other, that seems kind of strange, but this is, like, if you don't know chapter 4, there's no way you're going to pass this class. I'm just putting that out there. There's no way I should let you pass this class, because the next class you take in Java 2, you're going to do inheritance, and you're going to keep doing stuff on classes, and it's just going to get even more complicated. My midterm is heavy on testing your ability for knowing the information covered in chapter 4, and so is my final. Okay, so I'm just putting that out there. If it seems strange, first thing you do when you get home tonight, and what you should do all weekend, is read the book, try to write programs, try to understand this, go see the tutor, watch videos, like try to get this down. And like with any language that you learn, programming language is just the same. You have to have like strong repetition, like daily practice, over and over and over. If you're one of those students that wait till the last minute to do your work before it's due, then you're not going to be successful in this class, right? It's just, or programming at all. That's just the way programming is. It's either you know it or you don't, right? I got an A in Spanish. I still can't speak Spanish. I don't know how I did it, but like I just crammed and I was able to pass tests, really, right? But programming is not like that. You have to actually know what you're doing, okay? All right, so with that example, we can see like the benefit of writing a class that manages data for a student, right? Because if I wanted to make this program more complex, I can now invoke or instantiate another student object and manage that data that way. All right, so let's look at another example. Okay, so one of the examples from the book that I think is actually pretty neat is a class for a die, right? So you have a pair of dice, but one of those die is something that we can write a class for. Okay, so let's think about a die. Okay, so here's a die. All right, and it has 6 sides to it. Like you have like a dot here, maybe 2 here, 4 here, and then like you have the other numbers. Like basically the values go between 1 and 6. Okay. Now some services that a die will provide is that you can actually, so some simple services that it provides is if I'm just a person observing this die, right? There's my eyes. You can actually look and see what the face value is, right? So you can do what we call get face value. Okay, we have like a service called get face value. Those are supposed to be eyes, by the way. They don't look like eyes anymore. All right. One of the other things that we can do with this die is we can pick it up and we can change what value is facing up, right? So that would be like us grabbing it with our hand, right? And then setting it to some value, and that would be our set face value, right? Where we know we want it to show 2 on top, so we just pick it up until we find the 2 and then set it down when 2's showing on top. Okay, so we have a get, we have a set, and then one of the other things that we can do with the die is we can pick it up and just shake it up a little bit, throw it on the ground, and get a random number, right? So do it like that, I guess. Let me see, how would I animate row? So row would be like, right, and that service is called roll. We can roll the dice. Actually, let me change this to a lowercase r, not to confuse people. So, hey, how do I erase? I thought I could erase on this thing. All right. So according to our coding standards, methods start with a lowercase letter. All right. So there's three services: we can get, we can set, and we can roll. A die is actually like really, really simple. Okay. So if we're going to write a class for a die, we can include those methods. Okay. So like, what instance data do you think a die has? Instance data is the information that we are going to retain on the die. Like for a student, we retained name, test 1, test 2, and test 3. But for a die, what data do you think we should keep track of? Exactly, just the face value. And there really isn't anything else unless this is like a die for a GUI or for like a game. In that case, you might want to, like, dice could be different colors, right? Stuff like that. But in the sense for what we're doing, the only information that is pertinent to us is the actual face value. All right, so the die class is actually pretty simple, not as complex as our student class. So I'm gonna come over here, I'm gonna say new, and I'm gonna come over here and save this as, I'm gonna say die. All right, so this is a class that I am going to use so that I can instantiate die objects. So we call this a blueprint class. Okay, this student class here is a blueprint for a student. This die class is going to be a blueprint for a die. So I'm say public class die, right? Open close curly braces. So everything inside of here is going to be what I have for my class. So I'm going to say private int face value. Okay. All right, and then I'm going to have public void set face value, and I'm going to take in an integer of some value. Oops, why did I put a curly brace there? And I'm going to say face value is equal to the value that's being passed in. I'm going to have a method for getting my face value. So here I'm going to say int, and I'm going to say get face value. Oops, sorry. And then return face value. All right, pretty simple so far. That's all I'm going to do for now so that we can see how this works. But we have a face value, and once you declare that instance data, it's always good practice to create the setter and the getter for that value. So far the only services I'm providing are just two. Wait, wrong one. Click the wrong one. Are two, which is getting the face value by just observing the actual value that's showing, and then setting the face value is where I pick up the die and I set it to a particular face that I want. All right, so I'm going to come over here, file new, and I'm going to save this one as, okay, so I'm going to call this dice game, or how about die test? Die test. Because really I'm not going to make a game, I'm just going to test this die object. All right, so public class die test, and then public static void main string array arguments. All right, so I'm going to instantiate a die object. So I'm going to say like die1 is equal to new die open close parentheses. I don't have a constructor, so I'm just going to use the generic one where it's just empty, like there's no data being passed into these parentheses. All right, so I'm going to just call some services on this. So the first thing I'm going to do is say system.out.println, say die1 face value is, and then say die1.get face value. All right, now what I'm going to do is I'm going to say die1.set face value. Okay, I'm going to pass in 5, and then I'm going to print out what the face value is. Okay, then I'm going to test it one more time. I'll say, okay, well, let me change it to a 1, and I'll print out what the value is. Then I'm going to just test it one more time, and I'm going to print out a negative 999, which doesn't make sense for a die value, but I don't have any restrictions on what my method is actually doing, so the value is actually going to take. All right, so let me run this die test. Compile die test and then run die test. Dang it, I messed it up. All right, so there you go. So the very first value of the face value is 0, right? So I instantiated my die, right? And then the very next line was we printed it out. So but I didn't change it, the value of the face is 0, which doesn't make sense, right? Because the die doesn't actually have a 0, like a side with 0 dots on it, or no dots on it. Then I set the face value to 5, and then you can see that I got the 5. Then I set the face value to 1, I got the 1, and then you can see I set the face value to negative 9999, and I got negative 999. Now, what's the point of making something that die if I can change it to values that don't make no sense for it? Right? There really isn't no point. Do you guys agree with that? Like, I could just make a variable and then assign whatever I want to it and say this is the face value for a die. Okay. Now, the idea behind encapsulation, which is a term we're going to talk about in chapter 4, is that we make our instance data private, and the only way to change that is through the setter that you provide. So this setter has to be smarter to prevent values from being used that do not make sense for a die. Okay? So what I can do is I can come over here, and this is something we're going to talk about in chapter 5, which isn't too far away, so I'm going to go ahead and show this to you, is I can say, okay, well, I'm only going to set this die value if the value being passed in is greater than 0 and the value being passed in is less than 0. Then and only then do I want to actually set my face value to the value that's being passed in. So this is like a temporary variable. It just is like a placeholder to tell Java you're going to take in an integer. So when we invoked set face value here, this value was a 5. We invoked face value here, passed in a 1. The value that's being passed in here was a 1. When we invoked face value here, the value that's being passed here was negative 999, and we still took that value, but now with this new filter that I have, I'm going to prevent face value from being set to something that does not make sense. So now when I come over here, clear my screen, compile, and run, you can see that, dang, I messed that up. Totally messed that up, sorry. This should be, let's see. Well, that makes sense. So V is greater than 0. If V is greater than 0 and V is, oh, I put 0, dang it. What the heck? It should be 6. If V is less than or equal to 6, I'm sorry, I put 0, 0. So we'll talk about this more in chapter 5. Basically what we're saying is whatever value that's coming in needs to be greater than 0 and less than or equal to 6. Right? Those are the only values that we're going to take. All right, let me try this one more time. All right, and you can see that when I try to change it to 999, it did not take, right? Let me actually open my die test. I tried to pass in 999 right there, and it just remained 1, meaning it knew that value was bad. Okay? All right, but this value is still kind of messed up, right? So there's 2 ways to correct this value. Okay, there is just initializing your value to something that does make sense, like a 1, or the preferred method would be to make a constructor that initializes your data to something that makes sense. So the way we make a constructor is we say public, the name of the class, and then open close parentheses. Now if you want to take in some type of data, we could take in data inside of here. We can just say something like int value or v or something, but in this case I don't want to. Really all I want to do is just make sure face value starts off at 1 whenever we instantiate this object. So this right here is what we call a constructor. A constructor is the method that is invoked when you initially instantiate your object. So Java's going to come here and set face value to 1 and then say, okay, your object's ready to go. Okay, now some rules that you need to know for your midterm is the name of the constructor matches the name of the class. The name of the class matches the name of the file. All those 3 have to match. Okay, they all match. All right, so now let's come over here and run this program one more time. All right, and you can see that I started off at 1 now because my constructor initializes the value to 1. Okay. All right, so some other services that I want to provide on my die is I want to be able to roll it. So I can say public void roll. Okay, and rolling is simply just setting the face value equal to some random number between 1 and 6, right? So what I can do is I can just instantiate a random number right here, or excuse me, a random the random class here. All right, and if I'm going to instantiate it here, then I'm going to need to import java.utilo.random. All right, so I'm going to say face value is going to be equal to my random number generator, and then next int. Now, if I pass in a 6 here, what values do I get? You guys remember?
0 through 6.
No, 0 through 5. And then all I have to do is add a 1 to that, right? And now I get 1 through 1 through 6. Okay. All right. So now I have a new method to test, which is the roll method. So over here, I'm just going to take my die 1 and roll, and then print out what the value is. I want to do this a few times so I can see, you know, what values that are randomly being generated. Actually, let me change something real quick. I'm deleting all of them. All right, I want to just put like that I rolled inside of this statement here. Die 1 face value after roll is, okay. And I'm copying the method and also the statement. I'm going to roll it a few times. Save it, hop over here, compile and run. All right, so value after instantiation, value after setting it to 5, value after setting it to 1, value after trying to set it to -999. And these are all the values that I got when I randomly rolled it. 5, 2, like I got 3 2s, a 3, a 2, a 3, a 4, a 1, a 3, a 6, a 6, 5, right? I could keep rolling this and test the values. Whenever we talk about for loops, actually I could probably just show you that real quick since we are going to learn it like in a few weeks. Maybe actually by April we'll start talking about this. I can make a for loop here and like this int x is equal to 0, and while x is less than, we'll say 100, we're going to increment x. That means we're going to basically run this loop 100 times. That's what that for loop is doing. And if I wanted to know what roll I'm on, I can just put like the x right here and concatenate it to the string. All right, and I'll come over here, put in my screen, compile, and run. Okay, I ran it 100 times. It stopped at 99 because it started at 0. But if I look at what I did here, you can see that you can examine all this data and just kind of see what range the die is in. I really don't see anything outside of 1 through 6. But those are the 100 rolls that I did just to test to see what values I'm getting. All right, so I'm going to remove that because I have students who don't know how to use the for loop and try to use it, and I don't want them to worry about that just yet. So I'm going to remove it and just slap a bunch of them in here. All right, so that is a die. I mean, we made something that actually acts like a die object, right? Like we can make a game and ask the user, hey, do you want to roll the dice? And he rolls it and he gets some value. Okay, so one of the other things that I wanted to talk about with this is you also have, so every class that we create inherits from the generic object class. So there is a class called object. If you go to the Java API, you can read more about that. So we'll say like Java 8 API. We'll click here and we'll look for Java, wait, it was java.lang, I believe. Java.lang, click here. and then there's this class called object right here. All right, so every class inherits from this class. So what that means is our die is going to have all these methods available. Okay, this is something that you do not need to worry about, but the one thing I do want you to worry about is this toString. Okay, so what the toString is, it is a method that gets called whenever we output our die object to the console, right? And it's a method that gets called whenever we concatenate our object to a string. So what I can do is just right here, if I say system.out.println, like right after instantiating the object, actually let me put it on its own line. Okay, so I'll say system.out.println, and I can say die1. And let's just say I created another die, and I call this one die2. And I'm gonna print out that object as well. So those are the new lines that are added to this test. So now I'm instantiating another die object, and I'm printing them both out to the console. So I'll hop over here, clear my screen, compile, run, and these are the strings that were outputted. Okay, so let's think about that for a bit. So I didn't actually make a method that is generating that string. It was called on the underlining object class. So the underlining object class, what it's doing, it's telling you what the class name is, and it's putting like the ampersand sign. Is that the ampersand? No, it's not. Or what is that? I'm so confused. At symbol, I guess. And it's putting the memory location of where that object is stored in memory. That's what that hex value means. Okay? Now that doesn't really mean anything to us, right? Because we don't really care like where it's stored in memory, because Java does its own memory management. So we can do what we call override that method. Now, whenever you override that method, basically what you're doing is you're going to just mimic that method, but you're going to do something else. Okay? So the name of the method is public, and it returns a string, and the name of the method is toString. So I'm doing what I'm calling overriding the toString method, and I need to return a string that tells me something about my object. For now, I can just put like blah with exclamation mark, hit save, and now when I come over here, clear my screen, compile, run, you can see for both of those objects, it just says blah. Okay. I did what I call override. I overrode my parent's toString method. Now I want to do something that's more meaningful than just blah. Like maybe I want to know what the face value of the die is. So I can just use string.format and then make up some string that I want to see. I can say die, and then maybe like face value, and then %d for integer, and then pass in face value right here. In that case, when I come over here, clear my screen, compile, and run, you can see that both die1 and die2 are at face value with a face value with 1. Kind of don't like how I have space here, but not space there. Let me change that really quick. All right, come over here and put a space there. All right, so I mean, I can print out die1 like after every get now, and we can see the value actually change as my toString method is invoked. Okay, so there you go. There's die1 and 2, and then here's die1, here's die1, here's die1. It's always just 1. Dang it. Okay, but you can see that there's my toString, and I'm actually outputting something useful for my die. Okay. Any questions on this? Pretty intense, huh? Right. We're just separating the data from the actual driver. Okay. Now I do plan on like quizzing you guys like at least 2 quizzes a day, like starting now, before we start the class and before we end the class, right? Because this is something that you have to practice. Okay. So with that, I am done talking about what I'm going to talk about. I actually want you guys to write a class. So I'm going to go ahead and put up a quiz right now. Let's see. So, wait, I keep clicking on Java 2. Dang it. All right, so this is perfect. Okay, we just did this, but we did it for a die. Okay, so I want you to write a class for a coin that has instance data for its face value. So the face value is gonna, the instance data is gonna be the same. Okay, I'm gonna say let 0 be heads, let 1 be tails. So you don't have to worry about saying heads or tails. Just worry about getting back 0 or 1, right? And we'll just say when it's 0, it's heads. When it's 1, it's tails. Create a constructor that initializes the face value, similar to what I did for my die. Make getters and setters. I don't know why I made that plural, because you should only have one getter and one setter for face value. Okay, make a method called flip, which is similar to our roll method. The flip method would randomly set face value to 0 or to 1. Okay, so think about how you would do that. Really simple. And then override the toString method. Create a driver class that instantiates the coin object and invoke its methods. So very similar to what I just did. What I just did is on Dropbox. As I'm programming it, it does automatically save to Dropbox. If you need to take a look at that, you can, but this is the quiz that I want you to do before you leave.